welcome to a brief walkthrough of the Bitcoin Core repository and also my kitchen. Today we're going to be walking through the Bitcoin Core repo, the directory structure, what files are in there, where does stuff live, how do builds work, how do tests work, how can you write tests, and much, much more. So let's get started. So here we are in the README, which should look pretty familiar to you. We're just going to use it as kind of a jumping off point into some of the more interesting parts of the source tree. And what I'll do is just start with maybe the build process as a kind of entry point for how we prepare a Bitcoin binary, and then we'll dive into some stuff from there. So when you clone down the repository, you don't actually have the Makefile here. That gets generated by calling this autogen.sh file, which uses a sort of controversial build system named AutoTools to generate a Makefile that's pretty gnarly. The source of the controversy there is that AutoTools is seen as kind of antiquated relative to more modern build systems like CMake, but we have to deal with it anyway because we just have such a mature usage of it built out. So then once we've run AutoTools and generated this Makefile, we need to actually get the dependencies. And one way that can happen is by calling makeDepends. So everything in this little subtree here, the depend subtree, allows you to basically easily obtain all the dependencies necessary and do that through AutoTools. So I won't get too deep into here because it's pretty complicated, but we'll also go into contrib, which is another part of the source tree, because we need to obtain a certain copy of BerkeleyDB if you're going to build the wallet. And so we have a little utility script here called install db4 that does that. So contrib is basically just like a collection of scripts that you might find useful throughout development. You know, you can see in here, I don't know why we have a Debian copyright file, but I guess maybe we use that for rendering the Debian package. We've got some dev tools in here, things like Clang formatting, circular dependency detection. There's some security check stuff in here that you can run against built binaries, some symbol checking that goes on within binaries to make sure that we're only linking against things that we kind of expect to. So anyway, there's some interesting scripts in here. Near and dear to my heart, there's a UTXO snapshot generation script in here. So there's some fun stuff you can poke around with. Also in contrib, we've got the Gideon infrastructure, or some of it. We have a listing of Gideon keys from people who have commonly built the releases deterministically and verified the binary fingerprints. We've got some other Gideon infrastructure living here. So again, Gideon's pretty important, or has been historically important, because we use it to build the binaries in a deterministic way at release time, and that allows various people in the community to attest to the fact that the binary that we're releasing is built from the source code that's publicly available and expected. This next folder here is for Geeks, and that's actually the system that we're in the process of moving off of Gideon onto, because Geeks is a sort of more modern deterministic build system that Carl Dong has been doing a lot of work on. So I think there's a README here pretty comprehensively describing what's going on in Geeks land. So definitely check that stuff out, participate in the deterministic build process if you have time, because that's really important. it's a really important thing to have a lot of eyes on. So this init thing, I think this is just systemd configuration or initd configuration. Yeah, we have a bitcoind service file here. Again, we're under the contrib folder, so this is just kind of a lot of miscellaneous scripts and stuff. Linearize, I'm actually not even familiar with. Okay, I guess it's for constructing a linear no fork version of the chain. So if you want to generate a giant chain of headers that has almost no work associated with it, but just tests that your node is going by the most work chain and not the longest chain, I guess this is kind of useful. Got some Mac deploy stuff, presumably related to building on Mac platforms. We've got message capture, which I think was recently added. Let's check that by running git blame. Yeah, recently added by Troy, October of last year, and that's for helping to capture some of the peer-to-peer traffic. Seeds. Okay, so we're generating a list of seed nodes for chainparams.cpp. That's related to bootstrapping peers initially. So if you start up Bitcoin and it doesn't have any peers previously configured, then we need to figure out some peers, and so we go to some DNS seeds. In the really early days, I think this was done through IRC. So we've got some shell stuff. Got some Signet utilities. Test gen, some base 58 encoding, decoding stuff. Verify commits, I think, are maintainer tools. So here are the trusted keys for signing binaries, presumably. Those probably, at least some of those belong to Vladimir, who's the lead maintainer at the moment. Binary verification tools, Windows deployment infrastructure here, and probably some ZMQ example scripts. Yeah, so ZMQ is it's a library for doing socket-based communication, and we offer some hooks in Bitcoin to get ZMQ publications on things like block and transaction reception. So that's everything for the most part in contrib. There's some, again, some Gideon build stuff in here, but you can check that out at your leisure. So this DB4 tree actually gets built out if you use that install DB4 script. And again, that's just a particular version of the Berkeley database, which we use for the wallet at the moment, but I think there's pretty broad consensus that we want to actually swap out use of Berkeley DB with SQLite, which is a much more common, much more widely used library than Berkeley DB. But of course, managing that migration is gonna be an important thing to get right, because a lot of people have wallets in Berkeley DB, obviously. Okay, so we talked about the depends subtree. Doc is a good one to know about it, and it's a good one to check back frequently. I'm guilty of ignoring the developer notes more than I should, but there's just various stuff in here. I think it's all worth kind of pouring through. I guess we've got a BIPs table. We've got some discussion on how the benchmarking framework works, which we'll talk about in a second. So there's just a lot of stuff here to dig into. You know, we've got an overview of the multi-process Bitcoin project. All good stuff to kind of be familiar with. And of course, the release notes live in here as well for each version. So if you ever want to brush up on your historical Bitcoin knowledge, maybe a good thing to read through. Share, I don't think has very much. This is probably, yeah, okay, so this is like an example Bitcoin configuration file. Some Qt XML that I really don't want to dig into right now. So share's kind of uninteresting. It's not a huge part of the tree. So now we can look at test here, and there's a lot going on, as you might imagine, in test. This mostly just houses the functional tests, and basically the functional tests invoke the Bitcoin D binary kind of from the outside, and basically they use the RPC and the peer-to-peer interface, RPC being remote procedure calls, so use of, say, the Bitcoin CLI binary. These tests use RPC and P2P to do system level or functional tests on Bitcoin. And so let me see if I can find a relatively simple test here. Okay, it's definitely not that one. That one looks pretty gnarly. Let's see, maybe DB crash. Maybe feature help sounds like a pretty simple one. Cool. So for these test scripts, they're written in Python, and there's a whole API of utilities that you import. Pretty much everything inherits from this Bitcoin test framework, and basically that allows you an easy way to set up, nodes, whether it's just one or a few, pre-install various chain data if that's what you want, define the network topology in whatever way that you want, and there are various assertion utilities that are provided. There are various wait for this action to happen, wait for this node to do this thing. There's all kinds of stuff. So if you want to check that out, you can go into test framework, and this is where that giant test framework class that everything inherits from basically is defined. So yeah, whenever you're creating a new feature or want to test some existing feature or have a kind of test scenario that you want to look at, you create one of these files, and it should be fairly self-explanatory. I mean, a lot of these tests are very sophisticated, and so they look kind of gnarly, but it ends up being the case that there's a lot of support code that's written just to facilitate whatever test it is. But it always boils down to a subclass of this Bitcoin test framework. So there's a lot of stuff there to pour through. As you would imagine and hope, the functional test suite in Bitcoin is pretty comprehensive. I guess worth note maybe is this combine logs.py script, which can be very useful because it aggregates not only the logs from the Bitcoin D nodes under tests, but the logs from the test suite itself. And so you'll be using this a lot if you're working on functional tests to kind of examine the aggregate logs of everything and try and figure out what's going on. So as you would imagine, in data, we've got some data that's used in these functional tests. So you can check all that out at your leisure. It's a really big asset to the code base, and it's important stuff to have. This fuzz subdirectory of tests is a little misleading because all it has is the test runner for the fuzz stuff. As we'll see later, the fuzz tests are defined in the C++ subtree, which is in source here, which I haven't talked about yet, but I will. So the lint stuff are various files that we use for doing static analysis on the code base, and this mostly gets invoked in CI, and oftentimes, frustratingly, is difficult to reproduce locally. So if anybody's looking for something to do and they know containerization, it'd be nice to have a sort of consistent way to run these back against your change set in a way that's cohesive with the CI. Sanitizer suppressions, I think, is just configuration for some Clang compiler features that we use, like thread sanitizer, undefined behavior sanitizer. These are compiler extensions that we have in Clang that help us find, concurrency violations or null address violations or undefined behavior. So I guess these are just maybe exemptions that we've configured. So util, I can't remember offhand what this stuff does, but I guess we can generate RPC off, and maybe this is just, maybe these are just tests that live outside of the test framework tree. All right, and that's about all there is in that test subdirectory.